Having made the vice as a standalone assembly, got the upper frame and pivot, whatever you want to call it, and the motor mounted to the base. It's got some structure now. Might be a temptation to go on and make the crank and the frame and everything else, which is the objective of the whole tool, but then the following work would become rather tedious. So the next big assembly, or the big component, is the hydraulic damper. A tube, a piston, some end caps, and an adjustable needle valve. So quite a few components in there to get going with. And then once that's done, what's left will be the crank and the frame and a few brackets and bits and pieces and some wiring. So next big assembly is going to be the damper. Don't want to be holding this too tightly, because I don't want it to be not round. So that needs to come out and turn it around. As you can see, they give you an absolutely giant piece of stock to make one of the end caps out of. It's going to come down to a lot of very thin material as well. I'm going to face that off, ream that out to 8mm. It says 11/32 on the drawing, but the rod that goes through it is 8mm, so mismatch of sizes there. Face it, centre drill it and ream it 8mm, and then I'll make a mandrel to hold this on, and I can get to all the sides and features by bringing it on and off the mandrel after I've bored and drilled it. So the plan here is to use this tiny grooving tool to bring this inner diameter out to fit that tube in, and then I'll go into the depth, which means I've got to make a groove cut into that bottom surface of about 3mm. And I'll move the tool along and cut the groove depth around this hole, about 3mm deep, and then clean up the remainder that's going to be in the tube. That's the plan. I don't know if that tool is going to stand up to it, but we'll see. Well, let's try this. It's a slightly thicker, slightly stronger tool. See how that goes along. It's not broke the tool, but it's not liking it. Do. Well, that was a pretty lucky hit. Just a clean up cut on there, and In we go. That'll press nicely. Yeah, we'll just go in there with a bit of a spring cut, I think. That's the top cap of the cylinder done. Oh, the chatter. But never mind. Probably better made out of aluminium again. Some of these parts are in some odd materials, they really are. Aluminium would have been a lot easier. I'm going to try and keep the casting radius in here. We'll have to see how that goes. I might end up milling off this casting surface or leave it there. We'll have to see. Okay, so that's 0.1 away from the surface. Okay. Now I have actually cocked this up. I did originally want that to be 14mm wide, but messed up in the arithmetic in moving over. So this is now just 12mm wide and it's a little bit off centre. I've taken far too much off this bottom edge here. In the drawing it wanted it 1/2 inch, so I'm not too compromised on that. And I'll just have to deal with the off-centeredness of it with the location of some of the other parts. It's not really critical, but it's annoying. That now needs a 6mm reamed hole in it. This is a 12mm pin, upside down end mill, and that is centered up on the radius of that boss. That's the only dimension that the drawing holds on that. Hole in the center of that radius. Not a brilliant execution, but the casting's all over the place anyway, so that was never going to be centered in all respects, but I didn't have to make it worse, did I? Some lovely jaw marks there where it nearly got dragged out the forejaw chuck. Oh, and I've put lots of dents in here as well, clamping it to the plate. So not a very good part at all really. So the new tool has turned up. Brake cylinder hone. Every expense has been spared on this, I assure you. So hopefully we can regard that as cleaned out and pretty round. I suppose I'll use this again one day, I don't know when. With the cylinder kind of making good progress. Next thing will be the piston, a little chunk of cast iron here. When I look at the drawing for this, it's just a lot of unnecessary, well not a lot, but a few unnecessary features. There's a unnecessary groove or counter bore in the bottom of the piston. It doesn't serve any purpose and it'll be very difficult to machine. There's also this chamfer, the 20-degree chamfer in the skirt of the piston. It doesn't do anything except the inside diameter is dimensioned off of that chamfer, which is kind of a little bit absurd. This has the look of something that was fabricated initially and then somebody drew it as a single part. So I'm going to base this on what these dimensions are, but some of the dimensions I'm going to have to make up myself or infer from some of these other bits and pieces that are put on there. I mean, there's a dimension there, for example, 51/64. Is it really? Okay. There's another dimension there, 1 inch and 42 thou. I really don't know where they're coming from. It's probably going to have to be forge or chuck. Another giant piece of stock they give you. Now that I've got this bored out to 20 millimeters, it doesn't really matter what dimension it is, but it's 20 millimeters diameter, 14 millimeters deep, kind of matches the drawing. I've drilled all the way through nearly, certainly when it's parted off it'll be all the way through. And I just want to get this thread started. Don't expect to be able to cut the thread all the way through, just get it started so it's square, and then I'll finish it off by hand after I've parted it off. So just make sure I can reverse it. Yep. And in we go. As usual with a keyless chuck. Loosens up when it goes the wrong way. But it hasn't worked out perfectly with the parting off because I'm going to have to kind of dig into this shoulder here a little bit to get me 25mm length out of it. Really do need to improve on that. Right. This is the piston. It's got a counter bore in the back of it of 20mm, so with a 20mm mandrel secured with a nut and a stud, I can centre up this piston and it is centered up. It's in a hexagonal collet block on a stop, so all I've got to do is move the table over by 8mm, drill a hole, move it around one flat, another hole. That'll give me my 6 holes at 16mm pitch circle diameter. Couldn't be easier. So there is one piston with its 6 vent holes or valve holes, whatever you want to call them. Just got to get it off the mandrel now. Hope it hasn't gotten stuck. Clean up and a tiny bit of deburr aside. It's one finished piston. Yay! Now this requires a 1mm hole all the way through this screw. So I've got the sensitive drill. The way this works is that it's free to spin, and you just hold it with your fingers and push it in. That way you get the feel of whether or not it's snagging, whether or not it's drilling. And it's not even in straight, is it? Did wobble about a bit. There is a needle that's going to go in there, and if I put a countersink in the hole, it'll be able to find the hole when it drops in. So that's a 90-degree spotting drill. That should fall in there. Yeah, hole did come through. Broken the corners on it. I'll just clear that. I'll just clear that hole with the drill, and that'll be that bit done. So that disc is the one-way valve, which will allow the piston to lift up. It'll flush all of its oil through those 6 holes. Coming down the other way, the oil's got to go through that little hole, which will have a needle sticking in it to adjust it. Make sure it moves freely, otherwise it will be very embarrassingly not work. It fits in there, got all kinds of grit in it, no doubt. That goes on there, it's got to be soldered in. That's the cap for filling it. Well, you can hear it's even working on air pressure. Yeah, could go into the pump business. There's a piston rod, and that needs to go in there, just like that. And I think I'm going to leave it like that. This needs a 1/8 hole all the way through it. Yeah, an 1/8, not 3mm, because the needle that goes through there is an 1/8 bar. Start off with a 3mm spotting drill. Get that in quite deep so that it cuts itself its own straight hole. And then I'll come through with a 3mm drill and then open it up at the end to 3.2, which is an 1/8. So that's gone in about 12mm, which is way up the flutes on this. Could be a straight hole. It's not hot, it's just that my fingers are cold and can't actually feel them. So there we go, and this needle is expected to fit in there, and what the assembly notes say, sweated in, whatever that means. I think it means soldered. I might think of some other way to peg that in, or I might have to solder it, don't know. As a dashpot or damper, that's pretty much all of the parts made. There's a couple of bits that need to be soldered together, but I'm not going to do that until I have to, in case anything needs to be changed. Messed up this pivot on the end there. That's not in the centre, so I'm going to have to somehow compensate for that with some of the other parts, but it's a good snug fit on the end. The piston inside, that's a good fit, that's all okay. This disc on the end is a one-way valve, so that it only damps one way, so when you pull it up it opens, lets all the oil freely flow through. There's a pinhole there, 1mm hole, and when you're pushing the piston down that will seal. The oil's going to have to go up that little hole, but it can't get out unless that needle has been lifted out of the hole. So that needle pokes into that hole, and this is how you adjust it, by moving that needle up and down. There was never, it's got to be soldered, there's never any way to adjust this screw at the top and have it stay in the same position, so I've made a little knurled lock nut as well. That's just a thin disc, about 2-3mm thick, knurled with an M6 thread in it, and that will allow it to lock that in one position. So that's all these pieces made. There's connection pieces that need to go on the top, there's a foot or a base that needs to go on the bottom of that, and that's what's coming up next.